morning, sir. Good morning, ma'am, and our esteemed guests. A very warm welcome to our Space Exploration Unit. Today, we would be explaining you the Chandrayaan-2, and we all are open to questions in between. I am Shrikant from class 12.
Hello, sir. Hello, ma'am. Myself Akshata Singh from class 11A.
Good morning, sir. Good morning, ma'am. I'm Sneha Yadav from 12th.
Hi, sir. Hi, ma'am. I'm Khushi Shetty from class 11.
We embark on a journey into the vastness of space to explore one of humanity's most ambitious achievement that has captured millions of imaginations of people from around the world, the Chandrayaan-2. It was launched on 22nd July 2019 at Sriharikota by the GSLV Mark III. The scientific objective of the mission was to expand the lunar scientific knowledge and develop the technologies inherited from the earlier Chandrayaan-1 spacecraft.
I am explaining the working mechanism that includes collecting UV samples from distant objects in space. The Chandrayaan is equipped with detectors to record position, energy, and quantity of the valuable data on the lunar surface. The visualizations recorded in cameras, captivating images, and animations obtained from Chandrayaan-1 help the scientists and the public to visualize the unexplored space and the universe. Making it more accessible and engaging, a Chandrayaan has a great impact on astrophysics and the knowledge of cosmos.
As I said earlier, the Chandrayaan-2 was launched by the GSLV Mark III. It is also known as the Geosynchronous Satellite Launching Vehicle or the LVM. It is one of India's most powerful and heaviest launch vehicles. The initial part of the launch was carried out by the solid rocket boosters, and the upstages were liquid fuel to propel the spacecraft out of the Earth's atmosphere.
Carrying payloads in the orbital craft that will enhance the scientific objectives of Chandrayaan-1 with improved resolutions. A highly complicated mission with many time-critical events divided into some phases. The Earth-centric phase. As a composite module, the lander will start on the orbiter with a mass of almost 3,900 kg, was injected into the Earth parking orbit of 170 by 40,400 km on 22nd July 2019. After 5 successful orbit maneuvers, it was inserted into the lunar transfer trajectory free on 14th August 2019. The lunar transfer phase. After 6 days of cruise in the transfer trajectory, it was inserted into the lunar orbit on 20th August 2019. The moon-centric phase. After reaching the lunar orbit of 100 by 100 km, the lander modules and the orbital were separated on 2nd September 2019. Vikram remained in this position for almost 4 days to verify and validate the performance of all subsystems, followed by a powered descent.
Chandrayaan-2 operated in the lunar orbit in a series of progressively lowering lunar orbits. The initial orbit was around 100 by 100 km. The orbital conducted various experiments and scientific observations, and to do so, it carried various equipments such as orbital high-resolution camera, solar X-ray monitor, Chandra's atmospheric compositional explorer 2, dual-frequency radio science experiment, etc. The orbital was designed to have an operational life of about a year, but exceeding expectations, it continues to operate and send valuable data.
Unexpectedly, the space agency lost contact with the lander just 400 meters away from the landing surface. The descent and soft landing were to be performed by the onboard computers on Vikram, with mission control unable to make any corrections. The reason behind Vikram lander's crash landing was that it tilted 410 degrees instead of the planned 55 degrees. When the Vikram lander tilted from its trajectory, the scientists could do nothing but be silent spectators. According to ISRO officials, the velocity of the lander was supposed to slow down from 6,000 km per hour to 0 km per hour in 4 phases. But the space agency lost contact with it minutes before the touchdown. Due to the change in trajectory and lack of speed reduction, the Vikram lander, along with the moon rover Pragyan, crash landed on the moon. There was an outpouring of support for ISRO in various quarters in the aftermath of the crash landing of its lunar lander.
Now looking at the findings. One of the most groundbreaking discovery was made by Chandrayaan-2 in August 2019, when the instrument detected the unambiguous presence of hydroxyl and water molecules. Changed to detected the distribution of an important gas named as argon-40. Plus, Chandrayaan-2 Large Area X-ray Spectrometer detected the presence of some major elements such as chromium and manganese for the first time. The point where the traces of Chandrayaan-2 were found is known as the Tiranga point. The scientific payloads also collected information about the solar flares.
Coming to the trickiest topic, Chandrayaan-3 is connected to Chandrayaan. Chandrayaan-3's lander touched down in the south polar region of the moon. as ISRO's official webpage on Twitter posted it. Welcome buddy, Chandrayaan-2 orbiter formally welcomed Chandrayaan-3 landing module. Two-way communication between the two is established and the mission operation complex has now more routes to reach the landing module. As per specifications, in addition to the Chandrayaan-2 orbiter, the lander of Chandrayaan-3 has the capability to communicate with the Indian Deep Space Network, a network of large antennas. The Tracking and Command Network said in 2019 that due to the precise launch and orbital maneuvers, the mission life of the orbiter has increased to 7 years. But sadly, it could not land perfectly on the lunar surface.
We all hope that ISRO will launch many successful missions and achieve a multitude of milestones in future as well. Thank you, sir, for visiting us today. That made us believe even failures can be a reason for our betterment in the future.